Hello people, welcome to another episode of the video series where we learn Kotlin following with the Codecademy's Learn Kotlin interactive course. In the last lecture, we went through loops and studied the first half of it, and now in this video, let's take a look at the second half. Let's get started. From the while loop. When repeating code, we may not have a range or defined collection to dictate the number of loops we need to execute, because as you might remember, in the last video we saw for loop, and when we were using for loop, we were defining a range or defining a collection to loop through. But sometimes this is not the case. We need some other functionality. For example, if we use a while loop, it repeats code as long as a specified condition is true. If we revisit the animation in the first exercise, we can see that Cody uses a while loop to hike until time is no longer less than 17. The animation in the first exercise, let's take a look at it. Here, this one. I think in the last video I didn't visit this part. Okay. I think I directly started from the for loop. Shame on me. But yeah, so here we see a while loop, and it says while time is less than 18, continue hiking. So it goes up until it's 6 p.m. and when it's 6 p.m. it stops and then exit the while loop. Okay, you can take a look at this part. I will go back to while loop exercise and continue reading. A while loop is similar to an if expression because it tests a condition. And when the condition is true, a body of code executed. Okay, the main difference is the while loop will complete the body of code, check the condition, and repeat the code if the condition is still true. If the condition is false, the while loop is done and the program moves on. So here, the while loop checks if my age is less than 20, and then it prints something, and then it increments my age variable to 17. And since this is a loop, it goes back to here and check it again. And if it's still less than 20, goes inside another time, one more time, and then prints again, and then increments again, and then checks again, prints again, increments again, and until this condition becomes false. Because after a point, my age will become 20, and the check for 20 is smaller than 20 will be false, and when this happens, it won't go ahead and print this, but instead it'll exit and print that one. Okay, so while is a loop, whereas if is not a loop. While loops through the body, while the condition holds true. Okay, so yeah, for my age is 16, it prints, 17 it prints, 18 it prints, but for 20 it now exits the while. And since we have a println here, it'll print that part. If my age wasn't incremented inside the loop body, the loop condition would always be true and repeat forever. This is known as an infinite loop. Infinite loops lead to application crashes or other unwanted behavior. So it's important that they are avoided. When a while loop condition never evaluates to true, the entire block of code is skipped. So as a curious developer, I want to break things, right? So now I learned that infinite loop crashes applications. Let's see if it'll break Codecademy. So let's say we have a while loop doing just a simple print, maybe trying to break Codecademy. And then for the condition here, what I'm gonna write is just true, because I know that while this is true, this will keep printing forever, and this may crash the app. Let's see if it'll crash, and if my recording will also get broken. I don't care. I'm still in the beginning of it. So let's run. Okay. Yeah, it's turning, rotating. I think it gets stuck here in this infinite loop, so that it cannot update the screen and show the printed message at all. Yeah. And now we lost connection to Codecademy. Connecting to Codecademy, yes. Still rotating. I think I need to refresh the page. Okay, I'm gonna refresh it and come back. Yeah, refreshing solved the problem. But yeah, we created an infinite for loop, and it didn't print anything at all because it got stuck in this infinite loop. And also my run button died, so I couldn't run again or do anything else. It kept rotating and rotating. Cool. This is something you should not do in your programs. You should not ever lead to infinite loops. If you forget to put this statement, like my age plus equals 1, like the place you increment my age, if you forget to write this part, it'll keep rotating, because my age variable will always be less than 20, and this will create an infinite loop. Okay. When a while loop condition never evaluates to true, the entire block of code is skipped. So for example, we have a combined Boolean expression here. My age is greater than 12 and my age is less than 20. So my age should be between 12 and 20, but it's not. So this whole thing will get skipped without ever running this, because it'll check this condition and see if it holds first, and if it doesn't hold, it'll directly exit out of the while loop. Okay, so since we've set the value of my age to 11 and it's not between 12 and 20, the code block is skipped and the final println gets executed. Cool. Create a while loop. Let's do that. Just type while, a pair of parentheses again, which you place your condition inside, and the condition is counter is less than 5. So this will run where or while counter is less than 1, and a pair of curly brackets to create a body for this while expression, and uses a println statement in the loop body to output the variable counter. Okay, so counter increments the variable counter by 1 in the loop body, counter incremented by 1. You can use this. You can use counter equals counter plus 1, or even counter plus plus. I will use counter plus equals 1. Let's run. Okay, so since counter was initially 0, it passed this condition check and then printed when it's 0. Then it got 1 and then make it turn back to this part again and checks it again. And now 1 is less than 5, so 1 is printed, counter becomes 2. So 2 is less than 5, 2 is printed, counted became 3. 3 is less than 5. 3 is printed. Counter becomes 4, became 4. 4 is less than 5. Then 4 is printed, and then counter became 5. 5 is not less than 5, so it exits this while loop and prints this part. So you cannot see 5 here, because when this is false, inside of the while body won't get executed. Cool. The second exercise is to create another while, and now it has this condition. Okay, a strange condition. What does it mean? School grades index is not 6th. Okay, what is school grades? School grades is a list of school grades, and index is an integer that is 0 in the beginning, 0 initially, and I think we need to change this index to loop through this school grades collection. While school grades index is not 6th, so okay, when it is not equal to this string, then I should increment the variable index after printing the value of school grade. So school grade, I think I need to print school grades index first, and then go ahead and increment the index. I think that's it. When you're done, you'll see that the while loop exits once the element 6th is the current one. Let's see. Okay, started from kindergarten, and then goes here, 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 and whenever it's 6th, this condition becomes false and it exists without further going into this and that. Okay, if you want to see a step-by-step execution, let's follow me. This will take some time. So index is 0. When this line hit the first time, while expression will check if school grades index, meaning school grade 0, which is kindergarten, is not equal to 6th. Since kindergarten is not equals to this string, this whole thing becomes true. And since this is true, that means I need to execute what is inside the while for one time. And school grades 0, which is kindergarten, is printed, and then index became 1. And go back to the condition, because while is a loop. Now index is 1, school grades 1 is first, and since first string is not equal to 6th string, this is again true, and since this is true, it means I need to do what is inside. So I will print first and then increment the index to 2, and then I'll do the same and check if I find this, and then print it and then increment index. So each time these values are get printed until I see 6th. Cool. Okay, let's go to the next exercise. Another loop we have in Kotlin, in Java also, is the do while loop. It is similar to the while loop with having some differences in the syntax and semantics, like how it works. So a do while loop is just like a while loop, except the looping condition is checked at the end of the loop body. This is known as an exit condition loop and means the code in the body will execute at least once. So it first does the job, and then checks if the condition still holds, okay? Instead of first checking and then doing, it first does and then checks. So the order of checking and doing is reversed comparing to the while loop. This example shows that even though we have a false condition, my condition is false and while false here, our loop will still run the loop body once, I loop once, but without these exclamation marks. I think it's a mistake. One reason we would use a do-while loop is when our loop condition initialization and update commands are the same. Using pseudocode, we can compare a while loop with a do-while loop using how someone might decide to go outside. This is a real good example, by the way. Is it sunny outside? While not sunny, is it sunny outside? Stay inside. Go outside. The while loop example has a line before the loop to check if it's sunny outside. The loop is entered if it's not sunny and then repeatedly checks if it's the sunny outside. When it's sunny, the loop exits and it's time to go outside. So it's sunny outside, stay inside, while not sunny, go outside. So a better example could given like this. Let's say you want to go outside. You usually go outside first and then check if it's raining. And if it's raining, you go back and take your umbrella, which can be improved because if you first check the weather from your window and then take an umbrella, this will be a way better approach in solving this, okay? So it first checks, then does. So the while loop checks first, and if it passes, it runs the code, but the do while first does the job itself and then check if it should do it a second time, if it should do it a second time or a third time or a fourth time, okay? Okay, let's not confuse you by going into the details, but let's try to solve this exercise. Cool. We'll implement a do-while loop that performs a Celsius to Fahrenheit temperature conversion. Ooh. First, construct a do-while loop that checks if far does not equal 212.0. Okay, first, let's do a do while. So for this, you type do and a body and then a while and then a pair of parentheses where you input the condition. So condition comes here and codes to get executed comes here. Paste the following two lines of code. I think this is the codes to execute. Okay, where did it go? Yep. Sorry. And increment the value of index inside the body, I guess. Index plus equals 1. But what is the condition? Yeah, condition is if far does not equal 212. Far is not equal to 212.0. Okay. Let's run it first and then try to understand what's going on. Yeah, we passed this exercise without understanding what's going on. Let's take a look. We have a variable index, which is 0. We have Celsius temperatures, which are list of some random Celsius temperatures, I guess. And there's a Fahrenheit ratio, which is 1.8. And also another variable called var, which is double. We first print this title, Celsius to Fahrenheit. Okay. And then we start by assigning a value inside Fahrenheit, and that is Celsius temps index. Index is 0, so in the first run it gets this first Celsius temperature, and then times 1.8 and plus 32. So this is a formula to convert any Celsius temperature into a Fahrenheit temperature. So this is just like, you can replace this with 1.8 and delete this. Okay, just like a static formula. And the next line, it prints this, like the Celsius equals the Fahrenheit. Okay, so it creates this kind of visual listing. And then it increments the index. When it increments the index, but before coming to there, it increments the index and then checks if Fahrenheit is 212. Fahrenheit 212 becomes for 100 Celsius, so it'll stop there. But yeah, next time, since Fahrenheit in the first run is 32 and it's not equal to this one, this becomes true and it goes back to here and then calculates, but this time calculates, like converts Celsius temperature to, because this time index is 1 and we get 87 degrees. And this keeps running, first getting this value, then this value, then this value. When it is 100, 100 times 1.8 becomes 180, and 180 plus 32 becomes 212, which will exit the loop afterwards, after we see this. So you can see that this condition holds true for here, and then now it exits. Okay, let's go to the next one. Nested loops. Loops inside loops. Oh my goodness. A nested loop represents one loop placed inside the body of another loop, which results in a higher dimensions of iterations. This strategy is most often used when we'd like to compare the contents of two different collections or iterators. Below is an example of nested loops. The outer loop, this one, iterates through the range 1 to 2, whereas the inner loop, this one, iterates through the range A to C. It's important to understand that for every iteration in the outer loop, the inner loop will run through all of its own iterations. In the example above, the inner loop iterates 3 times for each of the outer loop's 2 iterations. Therefore, the println statement is run 6 times, because this will run 2 times and this will run 3 times. In total, 2 times 3, we have 6 times of execution. And inside the nested loop goes from A to C when I is 1. And then when I is 2, again J goes from A to C. So what is printed is this. When outer loop is 1, inner loop goes A, B, and C. Then outer loop becomes 2, and the inner loop went from A to C. The inner loop goes from A to C. When beginning with nested loops, they may seem difficult to work with, but they make advanced applications easy to implement. That's true. Like, these can go really complex, nested loops. You can place loops inside of loops inside of loops, and it gets harder to understand what is going where. So be careful with using inner loops or nested loops. But when you need, you must use them, and it will be one of the few ways to solve some complex problems. Okay. Instructions. You'll be building a grid of rows and columns, much like the ones that exist in Google and Excel sheets, using nested loops. First, start with a single loop. create a for loop that contains I as the loop variable in a range from 1 to 6 as the iterator. Okay, and with an empty body, I guess. Let's run this and complete the first step. Now you'll implement another loop inside the first one. So I'm gonna press tab and start from one indentation inside, and another loop. J is the loop variable in a range of A through F as the iterator. Now I need a print statement that outputs J first and then I and then a space. So J, meaning the letter, will be printed first, and then comes the I, the number. So this will be A1, B1, C1, D1, E1, and F1. Okay? For the first run of the outer loop when I is 1. Also, the empty space at the end of the string template is used to create a gap between columns, which helps us visualize what is happening in the code. But this will also print all of the cell numbers side by side. We cannot put this below unless we add an empty println statement to here. So if you put an empty println statement, it only prints a new line character. So it doesn't print anything, but then it jumps to the next line. So you can use this as a way of creating new lines or pressing enters, let's say. So whenever I do that, after each repetition, like whenever the nested for loop completes running, this println statement will get executed. So it'll hit an enter and then increment I afterwards. So that whenever the number changes, whenever I changes, it starts printing from a new line. Let's run this and see what I mean. See, now this println statement jumps, like creates these new lines at the end of each line, so that whenever we went through printing all of the cells in a row, then we jump and create another row. A1, B1, C1, D1, E1, F1, and then jump. A2, B2, C2, D2, E2, F2, and then jump. Nice. So this can come confusing or complex or sophisticated, and that's right, that's because it is. But again, after you get exposed to these kind of code so many times, you'll get better at understanding and writing it. So for the first few times, or for the first 10 times, let's say, it's okay to see the code, see the solution, or see how the syntax was, and try to copy and paste side by side and such. But afterwards, after spending so much time on it, you'll get better at it. Okay, next exercise. Jump expressions. The jump expressions break and continue are used to change the standard loop behavior by exiting a loop early. This is break. This is what break does. It exits a loop early, or skipping a single repetition, and this is continue. Okay? The break expression is used to exit the loop at a particular iteration. So, for example, let's say we have a list of numbers, my numbers, and let's say we iterate through this using a for loop. Okay, so each of the numbers inside my numbers list will be fed into this variable num in each repetition. So num will be 4, and then in the next iteration num will be 8 and then 2 and then 9. And we check if the 9 is greater than, if the num is greater than 9, and if so, we break. When you say break, it means exit the for without waiting without waiting for the completion of the actual condition. Just break whenever this happens. So whenever number is greater than 9, whenever we hit this 12, we just break and we don't print. So when you break, it directly exits. It doesn't continue running the statements inside of the loop body. In this example, the for iterates through the list of ints. Each iteration, the current number num is tested to see if it's greater than 9. If false, the number is output. If true, then the break expression exits the loop. And we can see that output stops before printing the number 12. 4, 8, 2, and 9 are printed, but 12 is not, because when this is true, it just broke the for loop and skipping altogether the rest of the code. Cool. Now let's learn about continue expression. It'll skip the current execution of the loop body, but the loop will keep going if there are iterations left. If the continue expression gets executed, any code left in the current iteration will be skipped. What does it mean? For example, the same example, but we have continue now in the place of break. So whenever I hit 12, it'll say continue. Continue means skip the rest of the code and continue to the next iteration. Okay, so it'll skip printing this one and continue with 7. And then when it's 16, it'll continue and skip printing the 16 and then continue to 10. And then it continues again to 3. So only the numbers which are less than or equal to 9 are printed as a result of this. If it's greater than 9, it won't get printed because we use a continue exiting that repetition, not exiting the loop altogether, but exiting that repetition. We have an exercise here. The code on the right is looking for something in different rooms of a house. Thankfully, we know that the item being searched for is in the living room. Okay, weird examples. Your job is to instruct the for loop to stop looking once it reaches living room. So we have a list of rooms. Let me adjust it a little bit. We have a list of rooms: kitchen, living room, basement, and bathroom. And we iterate through this room, the list of rooms, and we need to add an if expression here that tests if the loop variable room is equal to living room. Okay, what should we do if so? Inside the if block, println statement to output string found it. Weird, but okay, println found it. Inside the if block, add the appropriate jump expression that will stop the iteration. Okay, I think we need to write break, I guess. Yeah, let's run. Yes. Now, what does it do? It says kitchen. Now let me adjust it again. Kitchen found nothing. Living room found it. So if the room is living room, we print found it and we exit the loop. So it doesn't go to the basement or bathroom because we already found what we are looking, since we use break. Now in the second part of this exercise, we have a situation. As you can see, when we run our code, we get an arithmetic exception, divide by 0. If you try to divide something with 0, you'll get an error, like an exception is thrown, and your application crashes because it is indefinite. Like, what do you mean by dividing by 0? It's not defined. So, to get rid of or avoid this error, we will see if number which causes this exception is 0. And if it's 0, we will continue and don't do this operation, but go to the next repetition. So at the start of the loop, add an if expression that tests if a number is 0. If number is 0, then continue. Okay? If number is 0, continue. Continue means exit the repetition so that it won't execute the code inside the loop body, the rest of it, after hitting continue. Okay, let's run this. And yeah, we got the check mark. We got the check mark. Now let's go to the next exercise. And this is the last exercise, I guess. Yes. So label jump expressions. How would we use jump expressions inside nested loops? Good question. We didn't ask this question, but yeah. So the answer is labeled jump expressions. By adding a label to the outer loop of nested loops, we can execute a jump expression from the inner loop and have it act on the labeled outer loop. It's lots of mambo jumbo. So let me explain what's going on here. Let's say you have 2 for loops inside, and let's say you type break or continue or whatever, a jump statement, a jump expression. But how to tell which loop to exit? Okay, because you might break this for loop or you might break this for loop. To state this, you put a label to the for loops, like give for loops a name, so that you can describe, you can determine, you can denote which loop to break. Cool. For example, here it says RPS at. This is how you create a label. You go before that for loop and type this. And if you want to break this outer for loop, you just type break at RPS. The inner loop has an if expression that contains a break expression with at RPS appended when the condition P1 equals paper is true. Break at RPS executes and exits the outer loop. Okay, so rock, paper, scissors is what we iterate, and then inside the other loop, inside this loop, there is another loop, and this loop also iterates through rock, paper, and scissors. So it'll start like this: that P1 will be rock and P2 will be rock. P1 will be rock and P2 will be paper, and then rock and scissors. Then paper and rock, paper and paper, paper and scissor. Then scissor and rock, scissor and paper, and scissor and scissor. However, since there is a break statement, so if P1 is paper, we just go ahead and break it. So it doesn't go through the second or third iterations of the outside loop. So it prints this. A complicated example, but okay. Now let's look at what happens in our example when we change the break expressions to continue. Then we will skip where P1 is paper and we jump to scissors. Okay, so it's like scissor, rock, scissor, paper, and scissor, scissor here. Okay, label jump expressions. Good to know, Good to know that there is such a language feature, but you won't use this so commonly. So it's okay also if you don't understand what's going on here. Recall the 6x6 grid with A1 to F6 cells from the previous exercise. We'll take a closer look at how we can manipulate the structure and output of this grid using label jump expressions. First, add a label grid to the outer loop. So to create a label grid, we type grid first and then put an at and a space just before this for loop. I think that's all we need to do to pass the first check mark. And then we add an if expression inside the inner loop before the print statement here. Have the condition test if the inner loop variable is equal to C. Inner loop variable is J, so we need to test if J is equal to C. And if it's so, we will do something. But what do we do? I don't know. Yeah, just run this with empty body. Okay, nothing has changed yet. Inside the if expression, add a continue expression that jumps to the grid label. So we say, okay, continue grid. So it should skip one row, okay? Because the outer loop iterates through the rows and inner loop iterates through the columns. When you say continue grid, it'll skip one loop. It'll skip one row and continue from the next element in this range. Once you run the code, you should see a single line of output. The outer loop numbers go from 1 to 6, but the inner loop letters only group through B. What? Oh. Yeah. So, yeah, this was unexpected. Okay. I was mistaken. Sorry. So what's really what we really do here is something different actually. When we see the letter C, we continue. Since we continue, we don't even create a new line character or print the rest of the row, right? Because we just continue. It's not like just skipping a row, it's skipping the whole columns printed. So A1, B1, A2, B2, A3, BT are printed because when we come to C, we say, okay, next. And then it starts over with the I is where the I loop variable takes the next instance in the iteration. Okay, sorry for the misunderstanding, but yeah, as you say, like this is really really confusing. Even I, after all these years of coding, I can have hard times understanding what will happen in nested for loops with continue and break statements and such. So it's really okay for you if you don't understand or if you make mistakes. This will get better at time. And since we completed the loops, see you in the next episode.